Hello guys, welcome to this video. In this video, I'm going to walk you through the day 7 of Advent of Cyber 2022. Today's topic is about the CyberChef, and we will learn about what is CyberChef, what are the capabilities of CyberChef, how to leverage CyberChef to analyze a malicious document, and how to deobfuscate, filter, and parse the data. So for today's challenge, we have to start the machine first, and I have did that, and also I have opened it on a separate tab because it's much more bigger and visible. So we should deploy the lab first that we did. So first we should know about what is CyberChef. So CyberChef is a web-based application used to slice, dice, encode, decode, parse, and analyze data or files. The CyberChef layout is explained below. An offline version of the CyberChef is bookmarked in Firefox on the machine attached to this task. So let's just open Firefox. So let's open the bookmark, which is the CyberChef. So this is the layout of the CyberChef. As you can see here, the first part is where you add your text or the file. The second panel is the content is various functions, or also known as the recipes, that are used to encode, decode, or parse, or search, or filter the data. The third part is where you drag and drop the functions from the section 2 on here to create a recipe, and the output will be shown in this part here, and by clicking the big, you will pick or run the functions that are added from the panel 2 to the panel 3 to give you the output. You can just also check the auto big, that you don't need to click the big each time. So using the CyberChef from a mal document analysis, first of all we have to add the file to CyberChef. So let's do that. This is the file that we are gonna decode. I'm gonna just drag and drop it from into the input. And now what do we have to do? We have to extract the strings from using as shown here below. Strings are ASCII and Unicode printable sequences of characters within a file. We are interested in strings embedded in the file that could lead us to suspicious domains. Use the strings function from the left panel to extract the strings by dragging it to panel 3 and selecting all printable characters. So let's just do that. Let's search here for strings. Okay, let's just drag and drop it to the recipes, and here choose the all printable characters, and here we have to choose the maximize number. We can do it manually, or as you can see, it's written here that it should be 258 in order to see all the characters clearly. So let's just write it 258. So as you can see, now we can see all the characters clearly, but there are some random characters that are between each character, so we have to remove it. For that, we have to remove all the patterns that are here to see the clear text. So attackers often add random characters to obfuscate the actual value. If we examine, we can find some repeated characters like this. As these characters are common in different places, we can use regex or regular expressions within the find and replace function to find and remove this repeated characters. So in order to remove these repeated characters, we can use the find and replace function in the operations tab. So to use, we will put characters within the sequence, square brackets, and use backslash to escape characters. In this case, the final regex value will be this one. So let me copy this. Where /n represents the line feed as shown below. So I'm gonna come here and I'm gonna search for find and replace, drag and drop it here. So now As you can see, we have removed the unnecessary characters or the repeated characters, and we have the clear text here. So drop bytes. So after removing the repeated characters, we can see that the result that we are dealing with is a PowerShell script, and it's using base64 encoded string to hide the actual code. So the next function that we're going to use is drop bytes. To get access to the base64 string, we need to remove the extra bytes from the top. Let's use the drop bytes function and keep increasing the number until the top bytes are removed. So we have to drag and drop the drop bytes from the operations to the recipes and increase the length to 1 to 124 in order to get the base64 text. So let me search for drop bytes and just drag and drop it from here and change the length to 126. I'm sure it was like that. Let me check that. Yes, now we have access to the base64 encoded part. So after that, we have to decode it using the base64. Now we are only left with the base64 text. We will use the from base64 function to decode this string as shown below. So from this, we are going to use the from base64 and drop it here. Let me just search for from base64. As you can see here, I'm gonna drag and drop it here. We have the text, but we have to remove also some other parts. The base64 decoded result clearly indicates a PowerShell script, which seems like an interesting finding. In general, the PowerShell scripts use the Unicode UTF-16LE encoding by default. We will be using the decode text function to decode the result into UTF-16E as shown below. So we have to use the decode text function. Decode text, drag and drop it here, and here we have to choose the UTF-16LE encoding. So now we have a much more clearer result. So find and replace common patterns. Forensic McBlue observes various repeated characters. These are within the output, which makes the result a bit messy. Let's use regex find and replace again to remove these characters as shown below. So this will be the filter that we need to replace it. Come here and paste it here, and also let's find, drag and drop it here, and we want this to be replaced. Okay, now as you can see, we have a much more clearer result. So find and replace again. If we examine the output, we will find various domains and some weird letters like this before each domain reference. A replace function is also found below that seems replace this with HTTP. So as you can see here, we should replace this with HTTP. Let me copy this, paste it in the find, and replace it with HTTPS. Now we can see it's much more clearer. So use the find and replace function to replace. Okay, we did that so far. Extract the URLs. The result clearly shows some domains, which is what we expected to find. We will use the extract URLs function to extract URLs from the result as shown below. So let's search for the extract URLs and use this function. Extract URLs and add at the end of it. Now we extracted all the URLs. What's the next step? Next, we need to split the URLs. with the add function. The result shows that each domain is followed by the add character, which can be removed using the split function as shown below. So we can use the split function and split it with the add here. So let me just search for the split function. And this should split with add, and as you can see, now we have the final result of the text. So now we have to define the URL. We have finally extracted the URLs from the malicious document. It looks like the document was indeed malicious and was downloading a malicious program from a suspicious domain. Before passing these domains to SOC or the Security Operations Center, so if you want to know what is Security Operations Center, it's a team of IT security professionals tasked with monitoring, preventing, detecting, investigating, and responding to threats within a company's network and systems. For deep malware analysis, it's recommended to define them to avoid accidental clicks. Defining URLs make them unclickable. We will use the define URL to do the task as shown below. So let's just define it. Define URL, drag and drop it to the recipes, and we are done. So now let's just, great work. It's time to share the URLs and malicious documents with the malware analyst. So what is the version of the CyberChef found in the attached virtual machine? As you can see, the version is 949.0. 949.0. How many recipes were used to extract the URLs from the malicious code? I think it was almost 10. So if you count it, strings 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yes, it was 10 functions that we used to extract the URLs. And we found a URL that was downloading a suspicious file. What is the name of the? It's malware. The name of the malware. The name of the malware is mysterygift.exe. mysterygift.exe. What is the last defunct URL of the bandit Yeti domain found in the last step? So here it's the last URL. Let me copy this, come here and just open here, Control C and Control V. Good. What is the ticket found in one of the domains? Format domain, golden flag. So let's check it out. The golden flag is THM mystery flag. THM mystery flag. If you like the investigation today, you might also enjoy the security information and event management module. If you want to learn more, you should definitely check this module as well. So completed. So we are done with this challenge and for today's video. I hope you enjoyed it. So if you enjoyed the video, don't forget to like the video, subscribe to the channel, and hit that notification bell to be notified when I upload a new video. See you in the next video.